Prompt Engineering RAG Fine-Tuning. Hey everyone, welcome back to the channel. Here's a question I hear all the time. We're using ChatGPT at work, but honestly, I'm not sure we're getting everything out of it. Or, how do we go from copy-pasting into a chat window to actually building something useful? Today's video is the practical answer to those questions. We're going to cover 3 essential techniques for using large language models, LLMs, in a business context. Prompt engineering, RAG, retrieval augmented generation, and fine-tuning. By the end of this video, you'll understand what each approach does, when to use which one, and how to think about the costs and trade-offs involved. No fluff, let's get into it. Before we dive into each technique, let's get the big picture right. When businesses want to use LLMs, there are 3 main levers they can pull. First, prompt engineering. This is the art and science of crafting better instructions for an existing AI model. Zero additional training required. Can be implemented today. Often underestimated. Second, RAG, retrieval augmented generation. This is the approach where you give the AI access to your own data, company documents, databases, internal wikis, so it can generate answers grounded in your specific information, not just its general training. Third, fine-tuning. This means taking an existing LLM and training it further on your own data, so it becomes specialized for your domain, your style, your terminology. These 3 approaches differ dramatically in cost, complexity, and impact. Think of them as a staircase. Most businesses should start with prompt engineering, add RAG when they need proprietary data integration, and consider fine-tuning only when the first 2 aren't enough. Let's walk up that staircase. Prompt engineering is the practice of designing your inputs to an AI model to get dramatically better outputs. It sounds simple. The results can be remarkable. The first principle. Be specific. Write a sales email is a weak prompt. Write a concise first contact email from a senior account executive to the head of procurement at a mid-size manufacturing firm, introducing our inventory management software, under 150 words. That's a prompt that gets usable results. The most powerful technique in prompt engineering is called chain of thought prompting. You simply instruct the model to think step by step. Research has consistently shown that this single instruction can dramatically improve accuracy on complex reasoning tasks. The model isn't just pattern matching, it's walking through the problem. Another high-impact technique is few-shot prompting. You include 2 or 3 examples of the output you want directly in your prompt. This is especially effective when you need consistent formatting, for instance, generating structured reports, classifying customer feedback into categories, or extracting specific data fields from unstructured text. 2 more business-specific patterns worth knowing. Persona assignment, tell the model who it is. You are a senior employment attorney reviewing this contract for a startup founder. The model will calibrate its response to that expertise level, that audience, and that context. The quality difference is significant. Output format specification, tell the model exactly what structure you want. Respond with a table with 3 columns. Risk, likelihood, and mitigation strategy. This turns AI output directly into a usable business document, rather than a wall of prose you have to reformat. The beauty of prompt engineering. Zero marginal cost, immediate results. This is where every business should start. Once you've squeezed what you can from prompt engineering, the next step for most organizations is RAG. Retrieval augmented generation. Here's the core problem RAG solves. Any LLM, GPT-4, Claude, Gemini, was trained on data up to a certain cutoff date. It knows nothing about events after that. More importantly for businesses, it knows nothing about your company's internal documents, your products, your customer history, your proprietary research. RAG fixes this by building a bridge between the LLM and your data. Here's how it works at a conceptual level. Your documents, manuals, contracts, research reports, Slack archives, whatever, get processed and stored in a specialized database called a vector database. This database doesn't store text, it stores mathematical representations of meaning, so that similar concepts cluster together. When a user asks a question, the system first searches that database for the most relevant chunks of your documents. Those chunks get injected into the prompt, essentially handed to the LLM as reference material, before the LLM generates its response. The result: an AI that answers questions based on your data, with citations you can actually verify, updated as often as you update your database. Real-world example. A major law firm built a RAG system over their archive of 10,000 past cases and contracts. Attorneys can now ask how have courts interpreted this specific indemnification clause over the past 5 years, and get a synthesized answer with specific case references. What used to take a paralegal a full day now takes 4 minutes. Another example. Enterprise customer support. A company loads its product documentation, troubleshooting guides, and resolved ticket history into a RAG system. Support agents, or even an automated chatbot, can instantly surface accurate, current answers based on real product information, not guesswork. RAG's advantages. Significantly lower cost than fine-tuning, easy to update when your data changes, and it's auditable. You can see exactly what sources the AI used to generate an answer. For most enterprise AI use cases, RAG is the right first move after prompt engineering. Fine-tuning is the most powerful and most resource-intensive of the 3 techniques. In fine-tuning, you take a base LLM provided by OpenAI, Anthropic, or another provider, and you train it further on your own dataset. The result is a model that has internalized your domain, your terminology, your writing style, your decision patterns. When does fine-tuning make sense? There are 3 clear use cases. First, domain specialization. A medical device company trained a fine-tuned model on thousands of FDA regulatory submissions. The resulting model understands the specific language, structure, and compliance requirements of those documents, something a general-purpose model handles only superficially. Second, tone and style consistency. A large e-commerce platform fine-tuned a model on 10 years of their customer service correspondence. Any response the model generates now matches their brand voice precisely, the right level of formality, the specific phrases they use, even their approach to handling complaints. This is extremely difficult to achieve through prompting alone. Third, task-specific performance. If you have a very specific task, say, extracting structured data from a particular type of insurance claim form, fine-tuning on a large labeled dataset can outperform RAG significantly. But fine-tuning comes with real costs. You need quality training data, typically hundreds to thousands of carefully curated examples. You need technical infrastructure to run training jobs. And you need to refine-tune when your requirements change. The economics only make sense when prompt engineering and RAG have been exhausted, and the volume of the task justifies the investment. A useful mental model. RAG is like giving your employee access to a filing cabinet. Fine-tuning is like training the employee from scratch in your specific domain. Both are valuable. They solve different problems. Let me close with the mistakes I see businesses make most often, and how to avoid them. Pitfall 1. Overtrusting the output. LLMs are probabilistic systems. They can be wrong. Confidently wrong. For anything involving numbers, legal analysis, medical information, or high-stakes decisions, you need a human review step in the workflow. The AI said so is not a defensible business decision. Pitfall 2. Ignoring data security. Sending proprietary information to external API endpoints has real legal and competitive implications. Before you build anything, define your data classification policy, what can go to which models, under what terms. Some organizations build private deployments precisely to keep sensitive data internal. Pitfall 3. Skipping evaluation. How do you know if your AI system is actually working? Too many teams ship something and never measure it rigorously. Build evaluation frameworks early, even simple ones, so you have a baseline to improve against. And the single most important key to success. Start small and iterate. Don't try to automate an entire business process on day one. Find one high-friction task, build a focused solution, measure the impact, and expand from there. The teams that succeed with AI are almost always the ones that move incrementally and learn fast. Let's bring it home. Today we covered the 3 essential techniques for deploying LLMs in business. Prompt engineering for immediate, low-cost improvements. RAG for grounding AI in your proprietary data. Fine-tuning for deep specialization when the other two aren't enough. The competitive advantage in the next few years won't just be whether you're using AI, it'll be how well you're using it. The organizations that understand these tools at a technical level will make better decisions about where to invest and how to deploy. If you want to go deeper on any of these topics, let me know in the comments. And if you found this useful, a subscribe and a like genuinely helps the channel. Thanks for watching, see you next time. Thank you so much for watching until the end. If you have any questions or comments, feel free to leave them below. We're also looking for topics you'd like us to cover next, so let us know. Don't forget to subscribe and hit the like button if you enjoyed this video. Don't miss the next episode. Subscribe to the channel and hit the bell.